Explain the principle and the construction and working of moving coil ballistic galvanometer. The principle of this ballistic galvanometer is when a current is passed through a coil, it produces a magnetic field. When the coil is kept in another permanent magnetic field, a torque is produced in the coil. It is the simple principle of this moving coil ballistic galvanometer. The current passed through the coil suspended freely in a magnetic field. It experiences a force. The force is called as a torque in a direction given by the Fleming left-hand rule. Construction of this galvanometer. It consists of a rectangular coil of copper wire wound on a metallic or non-metallic plate hanged by means of a phosphor bronze wire between the poles of a powerful magnet. So this coil is hanged by a phosphor bronze wire. So the coil is kept between the powerful magnet. So the magnetic field is passing in this area. A small circular mirror is attached to a suspension wire. It is the small circular mirror attached to a phosphor bronze wire. The lower end of the coil, it is the lower end of the coil is connected to the hair spring. It is called a hair spring. On the upper end of this suspension wire and the lower end of the spring is connected to the terminals T1 and T2. It is the upper part of the bronze wire and the lower part of the spring is connected to the terminal T1 and T2. Here the power supply is given. This terminal is used to supply the power. Working. The ballistic is used to measure the electric charge, current, and etc. When the charge is passed through the coil, through this wire T1 and terminal T1 and T2, when we connect the external battery, a charge is passed through, that is, a current is passed through this. When a charge is passed through the coil, it produces a magnetic field. When the current is passed through any coil, it produces a magnetic field. Already a permanent magnetic field is there. There is a perpendicular magnetic field. Due to these two magnetic fields, the result of the magnetic field of permanent magnet, it gets, that is, the coil gets the high magnetic moment. Okay? So already it is connected, the coil is connected with the phosphor bronze wire. It has high magnetic moment of inertia. So it turns back and forth. So it produces the oscillation. Due to this two magnetic field and the inertia of the coil, the coil oscillates. The oscillation is measured by means of a light and scale arrangement. A light starts from here, so it incident on the mirror. This mirror deflects the light on the scale. When the current is applied here, the magnetic field produces. Already there is a permanent magnetic field. Due to this two field, the coil starts to deflect. Due to the high magnetic moment of inertia of this coil, it again turns back. So it starts to oscillate here and here. When it oscillates, the mirror also deflects. So when the mirror deflects, the light from the source of light incident on the mirror reflects. When the mirror moves, the reflected light also moves on the scale. So when we apply a large current, the deflection will be large. When you apply a small current, your deflection will be small. So the deflection produced by the mirror and the light spot is depends upon the charge current passing through this terminals T1 and T2. Now we will discuss theory. Consider this rectangular coil having the n number of turns. There are n number of turns placed in a magnetic field of magnetic induction B. So the length of the coil from here to here, length of L is small L is the length of the coil, and its breadth B is the small b is the breadth of the coil. So the area of the coil is length into breadth. When the current is passing through the coil, a moment, that is a torque, is produced on the coil. So the torque tau is equal to number of turns of coil N, the current passing through the coil I, magnetic induction produced by the magnet, and A is the area of the magnet. When the current passes for a short interval of time, so short interval of time is dt. So tau into dt is equal to NIBA into dt. Suppose the current passes for a t seconds. The total angular impulse given to the coil. So we are integrating on both sides. So initial time is 0, the maximum time is t. So integral 0 to t into tau dt is equal to NBA integral 0 to t I into dt. So we know that the charge Q is equal to integral 0 to t into integral I dt. So it is a general formula. So the total angular impulse given to the coil. So the integral 0 to t I dt is converted into Q. So NBA Q, let I be the moment of inertia of the coil about the axis. So it produces the moment in opposite side of suspension and oscillate with the angular velocity omega. Therefore, the change in angular momentum of the coil is equal to I into omega. It is equal to total angular impulse. So both are equal. So I omega is equal to NB EQ. They are the opposite torques. So the kinetic energy of the moving system, the general formula is of I omega square. It is the energy of I omega square. This energy is used to twist the suspension wire through the angle theta. And C is the opposite torque produced by the coil. Therefore, the work done in twisting a suspension wire by an angle theta is equal to half C theta square. So, this kinetic energy and due to this kinetic energy, the angle of twist, the angle produced are equal. Therefore, it is equal to kinetic energy of a moving system. So, half I omega square is equal to half C theta square. From this, I omega square is equal to Ct theta square. When it oscillates, the period of oscillation, capital T, is equal to 2 by root of I by C. And squaring this equation, we get T square is equal to 4 pi square I by C. So I is, from this we can modify, I is equal to T square C by 4 pi square. On multiplying the equation 6 and 7, already we have given the equation 6 here. So 6 and 7, so I square omega square is equal to T square C square theta square by 2 square pi square. From this we get I omega is equal to T C theta by 2 pi. On equating the equation 5 and 8, NBAQ is equal to this value TCQ by 2 pi. On simplifying, Q is equal to TC theta by 2 pi NBA. So these terms are separated, T by 2 pi and C by NBA theta. So the this equation gives the relation between the charge flowing and the balancing angle theta. So the charge is directly proportional to the angle produced by this. So these terms are taken as a constant k. So q is directly proportional to theta. When the charge increases, the angle also increases. When the charge, that is the current passing through the ballistic galvanometer decreases, the angle also decreases. It is the simple explanation about the ballistic galvanometer.